Now in chemistry, we often represent reactions using equations. So in this video, we're going to look at the different types of equations that we use to represent reactions. There are three common types of equations that we can use to represent reactions, and they are chemical equation, ionic equation, and ionic half equation. So what are the differences between the three different types of equations? This is what we're going to look at now. Now we're going to use the reaction as shown in the slide, magnesium plus hydrochloric acid, to give you magnesium chloride and hydrogen. Now what you see here, this is called a word equation. In chemistry, very rarely do we ask, will you be asked to write a word equation? So as a joke, I usually say that word equations are what we use in elementary school or primary school. Alright, in secondary school, we no longer represent reactions using word equations. So right now, I'm going to convert this word equation into a chemical equation. And how do we do that? Is to first convert each substance, each reactant and product, and to represent them by their chemical formula. So magnesium is a metal, so Mg. Hydrochloric acid, HCl. Magnesium chloride is an ionic compound, and if you can recall, the formula is MgCl2. And then hydrogen being a non-metal, you have to take note that hydrogen is a diatomic molecule, so H2. Okay, so the chemical equation looks something like this. Now in writing of chemical equations, it has always to be balanced. Okay, all chemical equations must be balanced. So in order to balance this equation, we need to add a 2 in front of HCl. Now in some questions, they will ask you to include the state symbol, so you need to ask yourself, like for example, magnesium is a metal, so it's likely to be a solid. All acids are dissolved in water, so aqueous. Magnesium chloride, if you look through the solubility rules, it is soluble as well. And then hydrogen is a gas. So this is the balanced chemical equation for the reaction shown. Now how do we get the ionic equation? There are a series of steps that we can use. I'm not going to go through them. If you need to, please look at the video for determining ionic equations, but I'm just going to write down the ionic equation straight away. So what is an ionic equation? An ionic equation is one which shows the ions that are undergoing reaction. So meaning, those ions that are not involved in the reaction, we don't show them in the ionic equation. Okay, so again, ionic equation only features the ions that are actually undergoing reaction. So for example, in this case, if you look at the ionic equation, we can see that the ion that's undergoing reaction is actually your hydrogen ions, okay, which will become your H2, and then your magnesium will become your magnesium 2 plus ions. Your chloride ions are not involved directly in the reaction, so they do not feature in the ionic equation. Now one thing to note is that when writing ionic equations, your state symbols must be given even if the question doesn't ask for it. Alright, so let us now compare the chemical equation in red versus the ionic equation in blue. Right, can you all see that in a chemical equation, you do not see any charges? That means you do not see any ions. So in writing a chemical equation, if you have to represent a substance or if there's a charge appearing, it means that you have written the equation wrongly. Okay? For an ionic equation, yes, you will see charges. There will be ions that are present in your ionic equation. That's why it's called an ionic equation anyway. Now that we have clarified the difference between chemical and ionic equation, let us look at the difference between ionic equation and ionic half equation. So let me first write down the ionic equation for the reaction that we were looking at. So this is the ionic equation. Now, ionic half equations are associated with the topic of redox. Okay, in any redox reactions, there will be a reduction reaction combined with an oxidation reaction. So meaning in any redox reaction, there will always be a substance that's oxidized, there will always be a substance that's reduced. So ionic half equations is to illustrate the reactions that the oxidation and the reduction reactions separately. Okay, what do I mean by that? Let's take a look at the ionic equation that we have written down. By analyzing the ionic equation, I hope you can see that magnesium has been oxidized. Okay, the oxidation state has increased from 0 to +2, whereas your hydrogen ions have been reduced to H2 because the oxidation state has decreased from +1 to 0. Right? So in order to illustrate the oxidation and reduction reactions, we can actually write down the ionic half equations. So this is the oxidation half reaction where magnesium is oxidized to magnesium ions, and then in the process it will lose 2 electrons. Alright, it will donate 2 electrons. If you can recall, when a substance loses electrons, it is oxidized. In the reduction half equation, we have the hydrogen ions taking in 2 electrons to form hydrogen gas. So once again, when a substance gains electrons, it is reduced. So if a question requires you to determine which substance is oxidized or reduced by means of electron gain or loss, the best way to do it is to write the ionic half equation, because from the ionic half equation we can see clearly whether a substance has lost electron or has gained electrons. Okay, so where else do we see ionic half equations? We see them in electrolysis as well. Okay, in electrolysis we have reduction occurring at the cathode, we have oxidation occurring at the anode. So the equations that you have been writing for the reaction at cathode and reaction at anode, those are your ionic half equations to represent the reduction reaction at the cathode and the oxidation reaction at the anode. Okay, so now that we have seen the ionic equation and the ionic half equations, what are the differences between the two? In an ionic half equation, we will see electrons in each equation. Okay, in ionic equations, you will not see any electrons. So if you are writing an ionic equation and somehow there's an electron in there, it means that your ionic half equation is wrong. Okay, and how do we get an ionic equation from ionic half equations? Is to combine the two half equations. If you can recall, in the topic of electrolysis, how do we combine the half equations? Is to make sure that the number of electrons on the left and on the right are equal. So over here we have 2 electrons on the left, 2 electrons on the right, they are equal. We can combine them together, and when we combine the two equations together, essentially we get our ionic equation.